Previously, we have explored our clusters based on the fluorescence values in each of the parameters. In this video, I'll demonstrate how we can now use the phenotype to filter and search for particular populations. Now, if we perform a similar search for this granulocyte population, not only could we sort for the X-mean, high to low, but we can now use the phenotype describing each cluster. So once again, I could search, have a look. This is our fourth biggest cluster. If I tick on, it will cover this. But we can see other clusters that might potentially be a very similar population, such as this cluster here. If we want to look more closely, I can turn off all of the non-clustered events. And whilst it's a little bit difficult to see, I can change the color to show exactly where this population exists. So here we have two populations. The software has been able to differentiate the events, but in this case they share the same phenotype, and at least on these two parameters exist in a very similar position. A more powerful way to try and identify different populations is to use the options in the filtering window. And here we have options to filter based on the cluster size. So we can filter, in this instance, the top 100 biggest clusters. We can filter based on the number of events within clusters. We can also filter based on the MFI in two parameters as displayed in the workspace, or we can use a combination of markers to create an exact phenotype, or simply select positively or negatively expressed markers to filter this list. And in this version of the software, we can also filter based on a gate that we can draw on the screen. And I'll go through these in more detail now. So the first filtering option is the number of clusters. So here I am displaying only the top 100 clusters by default. If I deselect this option and scroll right to the bottom, we can see there are, in this case, 27,500 clusters, but many of these are single events. So it shows that all events are considered in the clustering, but these aren't real clusters. The events do exist, but we want to filter these out. So this is where you can choose. You might want to show the top 200 clusters, filter, and then we can see that the 200th biggest cluster has 14 events, and we can decide if this is too small or acceptable to be considered a cluster. Another option is to define the cluster size. We might decide we want clusters with more than 50 events. So we can enter 50 to, and I'll put 1 million here. Turn this filtering option on, and now we can see we have 126 clusters with at least 50 events. We can cluster on X and Y MFI. So in the same way that we were sorting the X-mean and the Y-mean columns, if I turn our clusters off for now, I could enter a value here, so between 10,000 and 100,000, and I could type that in here and turn on. A new feature in FlowLogic is the ability now to autofill these values using a gate. So if I use the selected gate option, it will populate these fields. To do this, I can draw my gate. I don't need this plot open. I can move my cursor over the gate, it will highlight it. As you can see, it's red. And now if I click selected gate, you will see it will update the X and Y minimum and maximum values. And here we have our filtered options. We can combine this, so we might still want to show only clusters with greater than 50 events. And here, using this combination of filters, we have 4 different clusters, and very quickly we can see where they exist. So this option to populate the X and Y minimum and maximum MFI values using a gate is a much more efficient way than trying to read the values off the axes and then add them in manually. Alternatively, we could use the marker expression for our different populations. So we have an exact phenotype. So if I was to tick CD45, this would only show clusters with this exact phenotype. I could add additional markers, and then this will again show only those clusters with this exact phenotype. Probably a more useful way is to use the positive and negative marker expression options. So if I once again know my phenotype for a granulocyte population, I can say it has to be positive for CD45, positive for CD11b, positive for Ly6C, positive for Ly6G, and if I needed to, I could rule out a marker. So I could say I want negative for class 2. And that's another way that we can very quickly refine our search. And if I was to include these two values in the filtering, it still collects these because we know where these exist. And we're back at our original 2 granulocyte populations. The next steps in our analysis workflow are to extract these clusters as populations and display them in the file inspector, and this will allow us to graph them, perform statistical analyses, and build reports in DocLogic. We can also perform auto-gating to validate the clusters and build fingerprints from the clusters in order to search for similar or matching clusters in other files.